Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy them, so check out our friends at Linode. With 200 gigabit private networking, scalable shared block storage, a 40 gigabit public network, fast object storage, and a brand new managed Kubernetes platform, you've got everything you need to run a fast, reliable, and bulletproof data platform. And for your machine learning workloads, they've got dedicated CPU and GPU instances. Go to dataengineeringpodcast.com/Linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. And setting up and managing a data warehouse for your business analytics is a huge task. Integrating real-time data makes it even more challenging, but the insights you obtain can make or break your business growth. You deserve a data warehouse engine that outperforms the demands of your customers and simplifies your operations at a fraction of the time and cost you might expect. You deserve ClickHouse, the open-source analytical database that deploys and scales wherever and whenever you want it to and turns data into actionable insights. And Altinity, the leading software and service provider for ClickHouse, is on a mission to help data engineers and DevOps managers tame their operational analytics. Go to dataengineeringpodcast.com/Altinity, that's ALTINITY, for a free consultation to find out how they can help you today. Are you spending too much time maintaining your data pipeline? Snowplow empowers your business with a real-time event data pipeline running in your own cloud account without the hassle of maintenance. Snowplow takes care of everything from installing your pipeline in a couple of hours to upgrading and auto-scaling so you can focus on your exciting data projects. Your team will get the most complete, accurate, and ready-to-use behavioral web and mobile data delivered into your data warehouse, data lake, and real-time data streams. Go to dataengineeringpodcast.com/snowplow today to find out why more than 600,000 websites run Snowplow. Set up a demo and mention you're a listener for a special offer. Your host is Tobias Macy, and today I'm interviewing Adam Kocoloski about CouchDB and the work being done to migrate the storage layer to FoundationDB. So, Adam, can you start by introducing yourself?
Sure, Tobias. Thanks for having me on. My name is Adam Kocoloski. I work at IBM, and I'm one of the members of the project management committee for Apache CouchDB.
And do you remember how you first got involved in the area of data management?
Yeah, I was really on the sort of practitioner side more than the vendor side. In graduate school, I was doing work in experimental particle physics, and that is a very data-intensive exercise. You're looking for needles in very large haystacks, collecting tons of telemetry from these very large detectors about collisions between fundamental particles that are happening millions of times a second, and looking for really rare signals. And, the practicalities of that involve a lot of the kind of analytics that would be familiar to the folks who do a lot of work in Spark and things of that nature. And that was really my first introduction to data management. The database side of it came from kind of managing all the metadata about those data sets and the compute jobs that were processing them. And that's when I kind of got deeper into the way that people managed databases across universities, across national laboratories, across different regions of the globe, which is what got me interested in projects like CouchDB.
And my understanding of things like particle physics is that part of the challenge of the managing the volume of data is that you have to understand what data to actually even keep because it's coming at you so fast you can't even actually store everything, and so you have to have useful heuristics for knowing what to throw away.
That's exactly right. That's one of the most contentious parts of any particle physics collaboration is when you are making those online triggering decisions. And there's several levels to it. Some of that triggering decision work has to happen in FPGAs and things that respond incredibly quickly. And then you go to a next level that has a little bit more time to make a decision. Maybe it can run on a commodity Linux host and do some processing. And then, you ultimately get to a level where you say, yep, we're going to accept this event. We're going to write it to tape. We're going to write it to disk. And that's when all the reconstruction efforts go in to see how well your online triggering actually captured events of interest.
And you said that because of the challenges of being able to handle sharing of these data sets across different universities and organizations is part of what led you to CouchDB. So I'm wondering if you can just start by giving a bit of an introduction to how you got involved in the community and your current role.
Sure. I got involved in CouchDB because some of my colleagues from that physics research group and I decided we should take a stab at starting a company together. We saw a lot of the new innovations that were happening in the world of data management. This was around 2007 when you had papers being published by the big web companies taking non-traditional approaches to data management at scale. And we thought to ourselves, well, we're certainly embarking on some non-traditional applications of data management at scale in our own work, and we can foresee that other companies beyond the large-scale web companies would be interested in this kind of approach as they become more data-driven themselves. And so when we thought about trying to start a company, we zeroed in on this world of scalable distributed databases and said, okay, this seems like a place where we can really make an impact and where there doesn't seem to already be a leader in the market. And we did a little bit of a review of projects that were out in the open source world to see if there were things that we ought to extend rather than starting from scratch. And CouchDB at the time seemed to have a lot of the right mentality on its approach to data distribution, its approach to, empowering internet and web applications, and its approach to scalability. It just seemed really well aligned with what we wanted to do with our company.
And so if you can now give a bit more detail on the CouchDB project itself and a bit about what it is and some of the main use cases that it's well suited for and some of the ways that people are using it.
Absolutely. CouchDB is a project maintained by the Apache Software Foundation and has been for the past decade. It's imminently issuing its third major release, the 3.0 release, which I think is a culmination of several years worth of work optimizing, hardening, and really rounding out the support for some of the key use cases that it has served really well over the past several years. We find CouchDB to be an excellent general purpose database for building web and mobile applications. There's sort of in many of these projects, 80% of the functionality can be covered by a large variety of databases, and CouchDB is certainly one of those databases. So we don't see reasons, to disqualify it from many types of, sort of web applications that are being built today. Where it has a particular strength, though, is in its mechanisms for active-active data replication across a wide variety of topologies. Systems that might exist in an on-premises data center and another one in a cloud, deployments across different clouds, systems that want to maintain a local offline, editable repository on a mobile device or a tablet of some kind. Those kinds of situations where the data lives in multiple places and needs to be synchronized are ones that CouchDB finds itself especially well suited for.
Yeah, and I know that there are also projects like PouchDB and CouchDB Lite for being able to use the same type of interface and take advantage of the synchronization capabilities in things like browsers or in mobile devices. And so that was part of what I was initially attracted to when I first found out about CouchDB, is not having to deal with writing my own synchronization primitives to be able to take advantage of that same capability.
That's exactly right. Because that replication protocol is something that is, running as JSON documents over an HTTP interface. The sort of bar to implementing a client that speaks that protocol is lower than you might imagine, and that's where the PouchDB project got up and running. I think provides a very nice option for folks who are running in the browser like that, or running in sort of a browser-like environment in a mobile device. And I think that's something that I think speaks to the power of like open standards, open APIs, and internet protocols for fostering innovation at that level.
Yeah, it's definitely interesting how having a standard interface for a given application or particular use case frees people up to be able to spend their energy on much more valuable enterprises and the types of projects and products that come out as a result of that, where in some cases having a standardized API can be seen as a bit of a constraint that might be limiting in the capabilities that you have. But it's amazing the types of innovation that people can come up with even given those types of constraints.
Yeah, I'm encouraged to hear you, sort of point out the challenges of implementing one's own synchronization protocol. When you really get into the details of active-active synchronization of two different repositories that are being edited simultaneously, it becomes a pretty fun project pretty quickly. And I would say there's still a ton of active research in the field in looking at data structures that can intelligently merge edits from different environments, data structures that can intelligently track lineage between these different environments. So it's I guess the phrase "can of worms" comes to mind, right?
Yeah,
Embarking on the
definitely.
journey of inventing your own sync protocol.
Yeah, the CRDT, or conflict-free replication, or I forget exactly what it
Conflict-free
stands for,
replicated
but
data types, yeah.
yes, exactly. That's definitely an interesting area of research as well, and the types of use cases that enables. But as you said, it's challenging, and that's part of why it's not being used quite so ubiquitously as one might think. And in terms of the history of CouchDB, you mentioned that you first started looking at it in around the 2007 timeframe, and it was adopted by Apache in 2010. And that was in sort of the peak of the NoSQL movement, where people were trying to figure out different ways of having web scale or, massively distributed data storage layers, and some of the aspects of things like ACID and transactions that they were willing to forego in order to be able to handle these scaling capabilities. But then in recent years, people have started going in the other direction of moving back towards relational and transactional interfaces because of different breakthroughs that have been made in some of the architecture and compute environments. And so I'm wondering if you can just talk through a bit of the history and the role that CouchDB played in that NoSQL movement, and some of the ways that it has maintained relevancy and grown over the past several years.
I think that's an excellent summary of the past 10 years in the world of distributed databases. We sacrificed a lot in those early years in order to quickly achieve, new heights in scalability, as it were. And over the past decade have progressively tried to recover some of those richer isolation semantics and transactional capabilities that truly are pretty powerful primitives for application developers to rely upon. In the first versions of CouchDB, we had a system like the 1.x release, right, would run on a single server. It intentionally did not support like atomicity across updates to multiple documents, because we knew that that would be a particularly thorny problem to tackle as we got towards native clustering in the 2.0 release. But it had a model that was providing good isolation between updates to individual documents on a single deployment. In the next major release, the 2.0 release, and this is something that continues in 3.0, we adopted an eventually consistent system for replicating database, documents in databases across shards, and used the same basic revision tracking mechanisms that are implemented in CouchDB support for replication across instances as the way that we would converge on one view of the database in a CouchDB cluster. And that reuse had plenty of benefits. It meant that the protocol we used and frankly the implementation that we used was very battle tested, but it also had its downsides. The fact that these systems weren't executing any consensus protocol, they weren't providing any sort of rollback mechanism, meant that anytime you were concurrently issuing edits to a single document from multiple writers, you ran the possibility that these folks could race and that both could be accepted by different replicas within the cluster. So we certainly lived through a number of the downsides of sacrificing traditional levels of database isolation in the name of scalability. And I think, over the years, our users have understood the kinds of patterns that can be employed in application design in order to avoid that kind of contention. Nevertheless, the fact that they have to employ those kinds of patterns limits the ways in which they can design their applications to make the best use of the database. So I think we've had a front seat, I guess, at that that movie of how isolation and scalability have been in tension with one another in the world of distributed databases over the past decade. And I think we are, as a result, deeply appreciative of the power that strong consistency and transactional support can provide to application developers.
And this is probably getting a little deep in the weeds, but my understanding of the way that CouchDB was architected and the use cases that it was optimizing for was to prioritize write throughput. And one of the ways that it did that was by foregoing indexing on write and requiring those indexes to be built on read requests, which could sometimes lead to high latency in those read requests. So I'm curious what the current state of affairs is, and some of the trade-offs that have been accepted in the name of high write throughput.
Yeah, you've done your homework there for sure. CouchDB's materialized views have always been indexed on read. And that is very much a performance optimization, because those indexes were defined in JavaScript functions that the user would upload. We needed an environment that could pipeline the indexing requests through a configured JavaScript process, and firing up one of those for every single concurrent write was something that was harder to deliver high throughput out of. The trade-off being that those indexes were potentially inconsistent with one another. Each copy of the data, like each copy of a database shard, would be indexing independently, and that introduced additional potential for inconsistencies in the observability there. Like you might hit one copy of a secondary index on one request and another copy in another index, and guaranteeing that those things had a sort of a view that was progressing through time was an extra challenge for us at the clustering layer.
And I'm wondering if you can talk a bit more about the current architecture and implementation of CouchDB and some of the ways that it has evolved in those major revisions and the upcoming 3.0 release.
Sure. Yeah, we can dig into some of those things. The 3.0 release continues to bring with it the same fundamental architecture that the 2.0 release had, right? So we still have databases that are split into shards. Each shard's replicated. Documents are accepted by the cluster when a majority of the copies of those shards accept the write. Indexes are built on read. What 3.0 brings with it is, a lot of things that ease the administration of a CouchDB cluster by having auto-indexing daemons running in the background, by having automatic daemons that are vacuuming or compacting the database files based on an analysis of the workload. It brings with it a new full text search integration that gives people additional flexibility in defining their secondary indexes. It also brings with it one scalability improvement, which is essentially a support for compound primary keys, where the user has a little bit of additional control over co-location of documents. The way we have always answered view index queries in CouchDB has been a scatter-gather mechanism. Each of the replicas of a database shard builds its own copy of the index, and when you go to query that index, we have to go ask each of the shards what its contribution to that query is, because we don't know a priori which shards host relevant data for that query. What the new partitioning feature allows is for a user to say, every document sharing this prefix, a device ID, for example, or a user account ID in the case of a SaaS application, should be co-located together. And any query that specifies that first portion of the key in its query can be satisfied just by that one shard, rather than having to do the scatter-gather. So this is a much more scalable approach to indexing, and it's one that we find meets the needs of a lot of the different use cases for view queries in CouchDB. So that's a nice improvement coming in 3.0 as well.
And CouchDB being a document-oriented database, I've always been a little intrigued in the data modeling requirements of those types of storage engines, where at face value, when you're first starting off doing the Hello World tutorial, you say, oh, of course, documents are easy. I just have everything in one record. But then as you start to scale and want to try to do more complex analyses or try and figure out joins or how to be able to compose different records together, it starts to become much more challenging, and you have to get much more detailed and figure out how you're going to handle generating and then using these documents up front, rather than what is proposed as the sweet spot of these, where you can just throw documents in and then figure out after the fact what you're going to do with them. And I'm curious what your experience has been in that regard.
Yeah, I think that's a great perspective. I would say that the view engine has been a powerful assist to our users in that regard, because it gives you the ability to define an arbitrary JavaScript function that's executed over these different documents. If you end up with an evolving schema, it's possible to address those things not by a large scale data migration, but by some extra handling in the view code. We've certainly had users do that at scale. It's also the kind of thing that can do some simplistic kinds of joins by picking out, the related attributes of different documents that are different, sort of represent different classes of objects, and pulling them together into one view that then, you can issue a range request against that view to get a blog post and all of its comments, in one query to the database. So the flexibility of the view system has been something that has given people the ability to recover from changes in the data model over time, right, without a large scale migration. And it's also given them kind of the escape hatch to be able to cover sort of unexpected requirements in the application layer, without making fundamental changes to the model. But I would say, a lot of our users have found that the trade-off of being able to get to market faster has been a worthwhile one. For many of these people, like, the time to market has been, of the utmost importance. We had a lot of gaming customers for quite some time where, they had a very predictable measurement of the revenue associated with, launching additional games on the App Store and sort of turning their marketing machinery on it. And I can clearly remember conversations with them where they said, look, we know an evolution of the data model is really the right approach here, but when we do the math, it doesn't make financial sense for us to delay our release timeline in order to go through that remodeling of the data. So we'd rather just scale this thing out a little bit further and see how much longer we can make this last.
Yeah, the old space-time trade-off. And another implementation detail of CouchDB that I'm intrigued by is the fact that it's written, at least primarily, in Erlang, which I also know the React engine was written in, and a few other layers such as RabbitMQ. And I'm curious what you have found to be both the benefits and the challenges of that being the runtime for CouchDB.
Yeah, maybe challenges first. Erlang is not particularly well suited to high throughput number crunching. There are a lot of things that can be computationally intensive if done in pure Erlang. And so we've had to be fairly careful about what kinds of processing we do and be judicious about pushing things down into C code, as needed in order to hit our throughput and latency targets. That's been the main downside. I guess the other downside is the pool of developers from which one can hire is not as large as it might be in other languages. On the flip side, the people who know it tend to know it pretty darn well. And so there's a fairly high quality of developers in that community. Other benefits that we've seen, it's excellent for building cloud services, for building web services. There's a great degree of isolation. If a sort of rogue client process comes in and makes some crazy request, it can take down that TCP connection, but it's unlikely to have a bigger blast radius taking out other parts of the stack. That's something that has been a fundamental design principle of the Erlang system from its days powering telecommunication switches, which it still does today. The other thing that I think has been a real boon for us is the operational visibility into the system. The fact that you can kind of poke around in the running VM and gather a whole bunch of interesting diagnostics. And frankly, if you're feeling especially adventuresome, make changes to the running VM, is something that is pretty darn useful for chasing down the kinds of bugs that are, the Heisenbergs, bugs, right, that don't seem to lend themselves to an easily reproducible test case, but that are cropping up in these kind of strange situations in production. The Erlang VM, in my experience, is quite a bit more amenable to that kind of operational visibility than other runtime systems that I've been working with.
Yeah, I've heard some pretty remarkable statistics in terms of the reliability that you can get out of Erlang, such as I believe there was one company that's managed to have a system that had something like 5 minutes of downtime over the course of maybe a dozen years, which is pretty crazy.
It's fascinating. It is possible to design those kinds of systems and do things like, upgrade the code of a running process without actually restarting the lightweight Erlang process inside the virtual machine. And we've done many of those kinds of things over the years. There's a little bit of a tension with all of the world of container-based cloud-native programming in Kubernetes, right? Where Kubernetes and its ilk have their own opinions about how one ought to upgrade running services. And if you're really aspiring to upgrade the running code of a process without hanging up the connection, Erlang has tremendous tools in that space, but they don't necessarily lend themselves toward that kind of hands-off declarative notion of, let me go now upgrade this deployment in my Kubernetes cluster.
And so that brings us a bit into the replatforming work that you're trying to do with FoundationDB to replace the storage layer. And before we get too far into that, I'm wondering if you can give a bit of detail into the current way that CouchDB handles storage and some of the benefits that you're hoping to achieve with this replatforming.
Yeah, sure. So let's talk about the current storage engine. This is a storage engine that is entirely of our own invention. It is a fully copy on write storage model. Changes to a B tree index in one of our files involve rewriting the entire path from that leaf node up to the root and appending all of that to the end of the file. This is a very robust design. It always leaves the database in a consistent state. We don't have to do anything like replay, redo logs after an unclean shutdown. You can kill -9 a CouchDB process and start it back up, and it will automatically seek from the end of the file to find the last consistent snapshot of that file and use that. This is beautiful for operations, right? It very much simplifies a lot of the recovery processes that one would otherwise have to undertake in a more traditional database design. But that's just a description of the storage engine used for one replica of one shard file, right? Then you kind of climb up into the level of the eventually consistent clustering architecture, and that's a whole other ball of wax. So when we were looking at FoundationDB, our interest was not primarily in what you would think of as the storage engine, a RocksDB or a LevelDB or a SQLite or our own, CouchDB B trees. We didn't want to regress on that front. We thought it was really important to have a bulletproof, reliable, well-tested storage engine. Our interest, though, was in how do we provide, serializable isolation at that storage layer while also getting horizontal scalability. Right? And I feel like that's the problem that FoundationDB as a project has just basically spent all of its time trying to tackle. Let me provide a basic key value interface. Let me provide strict serializable isolation over updates to those keys. And let me do it in a way that allows for horizontal scalability across a cluster of machines. Those primitives were things that we looked at from a CouchDB perspective and said, wow, if we really had that underpinning CouchDB, we can deliver richer APIs to our users. We can improve the scalability of some of our operations, and we can sort of refocus our efforts on more of the things that CouchDB does that are truly like uniquely differentiating in the replication layer.
And in terms of this replatforming, I'm curious how you're planning to handle the sort of redistribution of features and capabilities within CouchDB, where it seems that in terms of the data replication, that can be relegated to FoundationDB. But I also know that CouchDB has out-of-the-box support for change capture feeds. And I'm wondering just sort of what the overall re-architecting will look like and where the capabilities will end up lying between FoundationDB and what role the CouchDB front end will serve.
Yeah, it's a great question. So our view here is that you can look at it as a set of layers, and that's how FoundationDB often talks about consumers of its data store. At the lowest layer, FoundationDB provides the durability. All of the data that CouchDB is storing is stored in a FoundationDB cluster, but that FoundationDB cluster is not directly exposed to consumers of CouchDB. On the top, CouchDB is providing, the familiar JSON HTTP interface, the materialized view indexes, other types of secondary indexes, search indexes, and so on and so forth. Those are all being written into FoundationDB. As the needs of an application using CouchDB grow, right, as its throughput requirements grow, that FoundationDB cluster can horizontally scale to accommodate more data and to serve more throughput. And the CouchDB nodes on top can horizontally scale because they're stateless. They're essentially an application layer over top of FoundationDB at this point. So we have good scalability stories for both the storage and the compute, if you like, providing CouchDB's interfaces. But all that said, that's one instance, one deployment of CouchDB. It's one endpoint that a user would interact with in their own application. If now you're saying, well, I'd like to have one of these instances running in my on-prem data center, or I'd like to have one running in US East and one running in US West, we view those as separate deployments of CouchDB, each with its own FoundationDB environment under the hood, and CouchDB takes care of synchronizing the data between those different environments.
And so it seems that this is going to impact the operational characteristics of running a CouchDB cluster as well, and some of the ways that users will need to think about how to actually deploy and maintain their systems. And I'm curious what in the sort of current states of how you've been working through and experimenting with this, the operational characteristics have improved, and any new edge cases or new considerations that operators need to be thinking about as they're designing these deployments.
Yeah, that's a great topic. And it's one that when we at IBM first proposed this direction for the future of the CouchDB project, we certainly got some questions on that front that said, it's all well and good for IBM to say, hey, we're going to run FoundationDB. You have the skills to go, put a team around that and make sure you can do it. What about the users who are running their own CouchDBs? How are we going to make sure that they're comfortable with the administration of this project? And I guess what I would say is a couple of things. One, FoundationDB is some of the best tested software I have ever seen, and that testing is not just about sort of the static, details of unit and integration and system testing. It's also introducing and injecting all kinds of random faults into running clusters and ensuring that the system ultimately, never sacrifices its ACID semantics and gets itself back up into a running state. It does make some different trade-offs. It's not it will take itself offline if there's a chance of data corruption, and it makes that particular trade-off in the cap triangle. But we looked at it not just from the perspective of the functional capabilities that it was providing in terms of key value transactions, but also in terms of whether the project had the same commitment to data safety, data protection, data durability that users have come to expect from CouchDB. And I think there's a really good match there. And I would say that our focus so far has been on the development work to bring over all of the capabilities of CouchDB on this, architectural foundation of FoundationDB. But we recognize that, getting in the run up to the 4.0 release, one of the things we're going to have to do is make sure that there's a familiar set of operational tooling for our existing users, so that even though they're running a different distributed storage engine under the hood, they're able to sort of be able to manage it in a way that makes sense to them. So yeah, I mean, it's clearly part of what we're thinking about in terms of the must-haves for the 4.0 release.
And another challenge that I'm curious about how you're handling is the migration path for people who have an existing installation. They've already got possibly sizable amounts of data in their existing clusters, and being able to move that to this new deployment with FoundationDB as the layer that's actually handling that storage.
That's right. So as a project, we have not typically tried too hard to do in-place major version migrations. We didn't have that from 1.0 to 2.0. We do anticipate that being something people can do from 2.0 to 3.0. But we think we think as a posture of saying, yeah, jumping from 3.0 to 4.0 requires a data migration is something that I think people will find acceptable. We do have plans in place to optimize the data replication capability specifically for this cutover from 3.0 to 4.0. And I think that's a smart allocation of resources on our part, because anything we do that makes data replication faster, more resource efficient, more reliable is something that helps out with a whole bunch of use cases, not just the 3.0 to 4.0 migration.
And so for somebody who is moving, would it just be a matter of deploying a new set of instances, joining them to a cluster running 3.0, and then letting all of the data replicate, and then phasing out the 3.0 cluster as you hit certain points of the different shards being replicated?
Yeah, we would look at it not so much as joining to the existing cluster, but just standing up a cluster next door and setting up a replication job to sync the data from the old cluster to the new cluster, and then having a load balancer over top repoint the endpoints to point to the new cluster.
And then as far as the actual work of migrating the code base and integrating with FoundationDB and figuring out what the separation of concerns are, what have been some of the biggest challenges and some of the most interesting experiences that you and the other developers have had?
If I go with challenges first, one of the things FoundationDB has done a good job of is being very explicit about the kinds of limits that are in place and the kinds of key sizes, value sizes, transaction durations, and so on are supported by the engine. In CouchDB, we've been a little bit more lax on that sort of thing. And so it has forced us to kind of come face to face with some of our relaxed postures around, well, how big of a document could you store in the database? Or how long could that request actually last? And, it's frankly been, I think, a conversation that we needed to have as a community, because at some point you just end up in a situation where you sort of say, well, I guess we didn't explicitly say you couldn't do this, 10 gigabyte document, but as a practical matter, it's not going to be a very good experience for you. Now we're getting much more explicit about the kinds of limits that are the sort of safe operating envelope for users of CouchDB. But it's never pleasant to introduce restrictions where there weren't any before, right? Because inevitably you end up breaking some edge case, in the user base. So that's been, just something that's occupied a lot of time and energy on our part as we, go through the audits to see, like, okay, where can we put this limit? So, and who can we work with to make sure that we bring all of our users forward as we get ourselves onto sort of a stronger footing overall. I think on the benefit side, I would say one, the FoundationDB user community and developer communities is incredibly sort of talented and helpful. You know, we've been amazed every time we reach out with any sort of design question. We get this like 3 paragraph answer that anticipates the other thing we hadn't yet thought of that we were going to run into. You know, the next time we came around to them. So that's been super super helpful. And I think as people have gotten deeper into the implementation of the CouchDB functionality on FoundationDB, I think there's just been a growing awareness of an appreciation for all of the powers of transactions inside Couch, and people are starting to come up with new ideas for ways that like that underlying capability can make our lives better as database developers.
And in terms of once this migration is complete and people are running a 4.0 release of CouchDB with the underlying FoundationDB engine, what are some of the new use cases that this might enable, or some new considerations in terms of the ways that people are designing their applications on top of CouchDB will need to think about, or any thoughts in terms of exposing the underlying FoundationDB engine as another interface for being able to interact with the data stored within CouchDB?
That is an excellent topic. So we have, as a community, said, look, our goal here, first and foremost, is to try to look at all of the different parts of the existing API and make sure that this is a relatively non-disruptive upgrade for our existing user base. That being said, it's incredibly tempting to look at some of the things that we can't do today in the CouchDB API that we might be able to do in the future with the FoundationDB storage layer. And so we have started having some of those conversations in the community that say, what could we do from a transactional perspective? Now that we have this underlying strictly serializable storage layer that scales across multiple machines, what could we do that we don't do today? And nothing committed on that front right now, but I think more and more people are appreciating that there's a real interesting opportunity there. You also talked about actually exposing the FoundationDB API, and I think that's a place where a lot of people go. They kind of look at it and say, is this like a multi-model kind of database where I can use the document API on the one side, the graph API on the other side? And I think what you find is that anytime you're working with FoundationDB, when you're building a layer on top, if your goal is to build the best document layer possible, you're going to make a number of design decisions that will be in tension with something that says, hey, I'm trying to build a multi-model database, therefore I'm going to create this completely generic data model under the hood that allows it to be accessed from different types of query languages and different types of APIs. So I have looked at it and said, I think the right way to think about this is FoundationDB as an internal implementation detail, and then you as a tool in our tool belt under the hood that allows us to deliver a great document database. And if over time someone else should say, hey, I want to build a great graph layer over top of FoundationDB, that makes the FoundationDB project better. But I'm not a huge proponent of thinking that FoundationDB is the right level of abstraction to allow people to have a common data model that can be accessed by different types of APIs and different types of query languages. I guess the last piece you said was, well, what about the FoundationDB API directly? And that one's an interesting one too. If you look at FDB today, it's got this kind of very tight coupling between the client layer and the server layer that is, a very different experience than, say, using CouchDB's REST API. The clients need to be kind of participating in the upgrade of the server, and they kind of need to be very cognizant of the version of the server that's running, and there's all kinds of details that go into that. There is some talk in that world that talk around introducing a more stable API, a gRPC API or something of that nature, that will allow for that kind of more direct exposure of FoundationDB. But that's not something that we as a project are really looking at. I think our view in CouchDB is that CouchDB is the kind of database that can be exposed directly as a cloud service, that can be exposed, powering web applications, that has the kind of security model, that has the kind of access control model that people need to have there. And FDB, frankly, just works at a lower level than that.
And one of the interesting things about using FoundationDB as the storage layer for CouchDB is also the fact that because it has this capability of implementing different types of data storage engines or databases on top of FoundationDB, is being able to have a common cluster of the FoundationDB engine with multiple different use cases on top of it. And I'm wondering what you have seen as the viability of that, or if it would just cause too much conflict in terms of the operational characteristics and what the different use cases are trying to optimize for in terms of compute versus memory versus network, et cetera.
Yeah, I that's something that we've turned over in our heads a couple of times here. I would say we have seen users of FoundationDB at scale embrace a single FoundationDB cluster for a number of use cases, but those are situations where it's kind of one development team, one SRE team that's cognizant of the different use cases, and they look at it as a you know a scalability improvement and an efficiency improvement for them to have one storage layer powering these different microservices with different data models. When you get a little further afield and the workloads really are very distinct from one another, they're not microservices powering one solution, but they really are like totally different databases designed for totally different user communities. That's the point where I would probably caution and say that the benefits of consolidating the storage layer onto a single instance of FoundationDB probably are not worth the potential for clashes and mismatches, like impedance mismatches in terms of the resource requirements of those different databases. Nevertheless, I think as an organization thinks about developing an expertise in the FoundationDB layer, I think there's still a ton of benefits to saying, hey, an organization that says we'd like to run the document layer of FoundationDB and the CouchDB layer and the graph layer. We have different users that want to do that, and we see benefits in an organization of saying we've got one operational team that runs the FoundationDB system reliably and at scale. I think that's something that makes a ton of sense, because I do think that these different data models, they still can be translated at that level of abstraction of FoundationDB into a set of, a transactional throughput, a key value, read throughput, a write throughput, and an amount of data stored. And, that kind of translation into those more low level resources is one that I think provides a lot of operational benefits and a lot of capacity planning benefits for an organization. So I guess that's a long-winded way of saying I would stop short of running multiple disparate workloads on the same FoundationDB cluster, but there are still a ton of benefits from different workloads all compiling down, as it were, to the common abstraction layer of FoundationDB itself.
And another interesting thing to explore is with CouchDB, there are different use cases that are obviously beneficial to the way it's designed, but what are some of the cases where it's the wrong choice and it might at first glance look like it's useful because it's just a document engine and you want to be able to store documents, but you would actually be better served using something else, whether it's a different document database or going with more of a relational use case or some other type of data model?
I think the number one that we see today is cases where you have very short-lived data. CouchDB spends a decent amount of energy on ensuring that data written into a database can be replicated to any peer at any point in time. And so there's a fairly long-lived set of metadata around each record that you put into CouchDB. And if you're intending to use it as a place where the record only has to live for a short period of time, and then you want to completely purge it, that will very much be at odds with all of the metadata tracking that says, well, we have to prepare for the case that some replication peer comes in a month later, and we want to make sure that they know that this document existed. These tombstones that we keep around forever today. And I think, as a community, we can debate the merits of that, and maybe we enhance things down the line to allow people to configure databases that are optimized for that short-lived use case and don't care about multi-region replication of that particular class of data. But as it stands today, if you have short-lived data, CouchDB is an expensive proposition for that use case. When it comes to sort of the relational side of things, I think that detailed ad hoc analytics are something that CouchDB is not particularly well suited for. True of other document databases in general as well, I think. It's well suited to delivering low latency responses to a set of queries that power a web application. It's not so well suited for mixed ad hoc exploration where you need all of the data from a certain set of fields, and then you need to go kind of compute a bunch of aggregations on the fly and merge that in with another data set. The relational model shines at being able to adequately serve unanticipated queries. Right? Document databases don't do as well on that front.
And what are some of the most interesting or unexpected or innovative ways that you've seen CouchDB used?
I think we're always heartened by the kinds of use cases that involve bringing workers out into the field. Like we've had insurance companies that had CouchDB powered on devices to go out and perform, claims analysis in the aftermath of a natural disaster. One of our collaborators in the community built an application for healthcare workers to respond to the Ebola crisis, where you could go through a day without any kind of connectivity, but you wanted to enable accurate record keeping as you were going out on the tour, but you still needed to roll that back up into a complete view of the state of the response, so that you could make the right decisions about where to allocate resources going forward. Those kinds of use cases have been an awesome fit for CouchDB, and it's just really, I guess it's not unexpected. I mean, that's the kind of thing we anticipated, but it's always great to see people kind of choose the right technology for the job and tackle something that is quite far afield from kind of us sitting in the major tech hubs of developed countries and building out more enterprise SaaS applications. So those kinds of things have always been really heartening for us to see, and it's turned into something of a trend there. I think we're also now seeing quite a lot of uptick in retail environments where they're starting to look at ways to have a more distributed view of the data sets at their different warehouses, shipping centers, points of presence, retail environments. And they're starting to look at the kind of replication mesh that you can get from something like CouchDB and saying, that's actually probably a really reasonable fit for us and has material improvements for like the availability of our system, for the independence of the stores. And it's just, our world in retail is distributed, and why shouldn't our database be distributed too?
And one other thing that I was just thinking about is we discussed a little bit about the changes in the operational characteristics once this shift to FoundationDB is complete. But are there going to be any changes in the client interface where there will be some exposure of things like the transactionality of the underlying data? Or do you anticipate that the user-facing interface is going to remain largely unchanged?
Our goal has been to make sure that this work in 4.0 is, an upgrade of the experience for our users, right? So our first focus is making sure we don't break existing user applications and we give everybody a path forward. We are super excited about exposing some more of those rich semantics up through the CouchDB API, and we've started those discussions about what would it look like to expose transactions in a database that is fundamentally, asking you to make an HTTP request for every interaction with the data store. So I look at that as a pretty interesting design opportunity, frankly. And I think there's a lot that we can do there that gives people transactional semantics in a cloud native world, without, sort of baking it all down into SQL. But, we kind of have to keep our focus. And I think our goal right now is to use FoundationDB to eliminate the eventual consistency of a cluster, to improve the scalability of our systems, with an eye towards, in future releases, surfacing more new semantics that take advantage of the transactional capabilities that we'll have under the hood.
And what have been some of the most interesting or challenging lessons that you have learned in the process of working with the CouchDB project and community and being involved with it for so long?
I would say that over the past decade, I've just gained an increasing appreciation for the all of the realities of bringing a database to production as a user, right? And writing the actual code that manages the transactions is just a small part of the overall picture. We've put a lot more effort in recent years into making sure our users understand how to deploy and manage and monitor the database, and have just been a lot more explicit about the way it works and the way it can be used. And I would say, like, my experience on that front has led me to place more and more premium on documenting our design decisions, ensuring that we have full documentation of what we're doing when we're doing it, because we've sort of gained a greater appreciation as our client user base has grown and matured. We've gained a greater appreciation for how much we can make their lives better up front with all of those sort of non-code assets that go along with the evolution of the project. And I think that's actually a really nice kind of echo of some of the things that go on in the Apache Software Foundation. Like, people sometimes think of committers to an open source project as the folks who are fundamentally changing all the core data structures on disk. But in fact, we invite committers of all shapes and sizes, a lot of people who don't program in Erlang, but they make these contributions in all other facets of the project that make it something that's more consumable and more reliable and more approachable for our users. And I think as you look at the project's evolution over time, more and more of our investment has gone into all of those other surrounding assets that make it a more well-rounded, more approachable project as a whole.
And circling back, one other thing I forgot to ask about is, because of the fact that this is such a drastic change in the implementation and architecture of CouchDB, there's definitely a lot of opportunity for introducing new bugs or regressions. And I'm curious what your approach has been to handling the testing and validation of the functionality of CouchDB to ensure that you don't have too many breaking changes.
Yeah, I mean, I don't know that we have any sort of special sauce there. We've got a robust test suite that we've maintained over time, and because we're committing to largely preserving the existing API, the existing test suite is something that we expect to be able to, run unadulterated. We've also got like a good performance engineering team at IBM who's looking at all of the other kinds of scalability issues and chasing down any cases where the new system may be a regression from the old one in some particular aspect. The Erlang community has done a lot of work in things like property-based testing, kind of really sophisticated types of fuzzing to introduce all kinds of unexpected inputs and see how the system responds. And we have some people who have done some work on that front as well. Usually it's about testing internal data structures more than testing external APIs because it is quite expensive to generate this kind of like huge phase space of test cases programmatically. But I feel like there's maybe some opportunity for that as well. I guess we also just have the benefit of having within IBM a large and diverse user base of people who are friendlies and are willing to work with us on this journey because they appreciate the benefits that we're bringing to bear. And so we've been able to lean on them early and often to help us suss out where anything might be happening here that's unexpected.
Are there any other aspects of the CouchDB project and its ecosystem and community, or FoundationDB, or the work that you're doing to replatform onto the FoundationDB engine that we didn't discuss that you'd like to cover before we close out the show?
No, I think we've covered a whole bunch of really interesting Gorpy aspects of building databases. I think that this approach of kind of a separation of concerns, right, and the API that FoundationDB offers is an incredibly powerful tool in the data service developers toolkit, and I'm excited to see more people adopt that line of thinking. I think as a database community as a whole, we'd be better off for it. So frankly, I'm just, I'm jazzed about the project and where things are headed.
Well, for anybody who wants to follow along with the work that you're doing or get in touch, I'll have you add your preferred contact information to the show notes. And as a final question, I would just like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
That is an excellent question. When I think of data management a little more broadly, I think that we've got a ton of people who are struggling to kind of gain as much insight as they can from the data that they've collected. And a lot of that comes down to kind of like the availability of good data catalogs that are integrated into the entire workflow. Like we've got all these users, all these clients who have databases scattered across their organization. And they know that in order to build a machine learning model off the data they're collecting from their application, they're going to need to do a whole bunch of data engineering, right? Data curation and transformation to get it into a shape where it's ready for the training of the model. At every step in that journey, you're creating more data, and you don't always understand how those data sets relate to one another. You don't always understand, when there's some correction in the source data, what types of downstream effects that has. And so I feel like we spend an inordinate amount of time and energy manually curating all of these data sets because of like the lack of capture of lineage information and how they relate to one another. And it's a super hard problem unless you're operating at a scale where you have like ruthless rules about how data gets processed because, there's no other way to do it than to use the one standard tool. Most of our organizations are not like that. People use whatever tools they want, but you end up with this explosion of data sets and very little idea about how they all relate to one another. So when I see, a gap in tooling or technology, for me, it's it comes down to this metadata management at scale. It just becomes a huge problem for everybody.
Yeah, that's definitely a common theme that has been something that's come up a lot of times in my conversations, but increasingly frequent in recent episodes and in the past several months and probably past year or so. Well, thank you very much for taking the time to join me and share your experience of the work that you've done with CouchDB and your work that's ongoing for replatforming onto FoundationDB. It's definitely an interesting database and product, and it's an interesting undertaking for something that has been in production for so long. So I appreciate you taking the time to share your insight and experience with that, and I hope you enjoy the rest of your day.
Thank you, Tobias. You as well.
Thank you for listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.